Okay, now this another type, I think it's the third method in which we have acid plus alkali, or you can say that as a soluble base. So we learned about this very well here, like acid and alkali, and we get a salt and water as a product. So here it's going to explain you in detail about the titration. What is titration? Let's see here and going to find out the reaction. Titration is generally used for preparing the salt as a very reactive metals. So very reactive metals, you know that, such as potassium and sodium, it would be too dangerous to add the metal directly in the acid. So you know that the reaction is very fast, vigorous, so you need not to do any types of direct contact with them. So in this case, we solve the problem indirectly and use an alkali which contain the reactive metal. You know this very well. Whose salt we wish to prepare. We need metal, but we can't add the reactive metal directly. Then what we use its alkali. Like here, you know that you want a sodium to add in acid, but you know this reaction is very dangerous. So what you do, instead of adding sodium Na, you make its or you use its base as NaOH. So this base actually going to give you metal, and the base go towards the hydrogen part of the acid and they make water, and here you get this soluble base. In this case, we solve the problem indirectly by use an alkali which contain the reactive metal whose salt we wish to prepare. Most metals, oxides and hydroxides are insoluble bases. They are said to be basic. A few metals, oxides and hydroxides that do dissolve in water to produce OH negative ions are known as alkalis. We learned this very well. Or soluble bases. If the metal oxide or hydroxide does not dissolve in water, it is known as insoluble base. Now, the alkali definition, it's going to tell you here. We already know that, we learned in detail about this one. So the alkali definition, it's mentioning here, soluble bases, aqueous solutions of alkali contain OH, any hydroxide negative ion. So here we're going to know about the base. So when we're going to discuss about a base is a substance which neutralize an acid. The first reaction, neutralization, you know very well about this one. Producing a salt and water as the only product. When any acid going to react with base, they gives you two things. One is salt and second is water. If this base is soluble, the term alkali can be used, but there are several bases which are insoluble. It is also a substance which accept a hydrogen ion, mean to say H positive ion. Okay. In general, most metal oxides and hydroxides as well as ammonia solution are bases. So OH and the oxides of metals and the ammonia solution, we name them as these are bases. Some examples of soluble and insoluble bases are given in the table, and they are all base insoluble. So like I gave you the example of the acids, so you know very well about them. Here you have the examples of couple of bases like sodium hydroxide, potassium hydroxide, calcium, and ammonium hydroxide. In all, you have NaOH, KOH, CaOH, like this. And their insoluble bases are iron oxide, the H you can say that removed from, and then it react with this and gives you a solution. So next we're going to see there. In this neutralization reaction, both reactants are in solution. So a special technique called titration is required. What happened during the titration? Acid is slowly added and carefully added to the measured volume of the alkali using a burette. So this thing is called burette, the long pipe-like structure. Here you have this one. In the lab, you can easily find out until the indicators, for example, thymophenolphthalein change color. So that going to show you the end point. The end point mean to say where acid and alkali or the base that going to react, they become neutralize each other. So that will be the end point of the reaction. And an indicator is used to show when the alkali has been neutralized completely by the acid. This is called the endpoint. So you should know that about the endpoint. So in the exam or in the question paper, they can ask you what is endpoint during filtration, sorry, during a titration reaction, okay? So you know that where the endpoints comes and what is endpoint. Everybody understand?
No, sir.
No or yes?
No.
Okay, listen. How the reaction going to complete, how you should know that the reaction that is going on here in the titration when you get your product, it's depend upon when the color is changed or when it show a specific color. Basically what type of indicator you use, it's depend on it. For example, you have 10 ml of base, okay? To neutralize this 10 ml base, you need, for example, 10 ml of acid. Okay. Sometimes it comes, but maybe sometimes due to change in its concentration, it will not going to equal amount. Maybe at 8 it become ends, or at 8 it become neutralize the reaction. But how you know that it become neutralized? Here in the conical flask, you add indicator like thymophenolphthalein that change color when your reaction is completed. When your reaction is completed, that point is called the end point. Here you stop adding your further acid in the conical flask. Now understand?
Yes.
Okay. Once you know where the endpoint is, you can add the same volume of acid to the measured volume of alkali, but this time without the indicator. So then you no need to indicator because you know that that is your endpoint. Only this amount of acid is required to neutralize a specific amount of acid, so you can get your product. For example, the salt sodium chloride can be made by reacting sodium hydroxide with hydrochloric acid using this method. So HCl, NaOH, you get NaCl plus water. This is the simplest equation, and you can easily learn by the formulas that you use here in the place of hydrochloric acid, HCl, sodium hydroxide, NaOH, then this dissociate from here and HCl dissociate here. Chloride and sodium combine, they make a salt, and from here hydrogen and OH combine to form water molecule. The previous discussion on page 120, this reaction can best to describe by the ionic equation. So that is your ionic equation in which you get water. It's just going to repeat this equation again. Now the sodium chloride solution which is produced can be evaporated slowly to obtain the salt. The hot concentrated sodium chloride solution produced is tested by dipping a cold glass rod into it. If salt crystals formed at the end of the rod, the solution is ready to crystallize. It is just a test. Before you make a crystals, you just dip the cold glass rod in the solution, and after dipping it out, if the crystals are there, you mean to say this solution is ready to crystallization and is left to cool. and crystals produced on cooling are filtered and dried between clean tissue. So after making, you just dry it and you can use them, or you can just strip it out from the solution on a filter paper. Now the last here, that is the fourth one, acid plus insoluble salts. So this types of salts, they are insoluble bases. So here again, you have acid and base, but you get here salt and water, but that is insoluble base. The last one is soluble base. Sorry, this is insoluble base. This method can be used to prepare a salt of an unreactive metal. Mean to say the metals, they are not going to react easily, or you can say as unreactive metal. The last one is highly reactive metals, okay, such as lead and copper. In this case, it is not possible to use a direct reaction of metal with an acid. So the acid is neutralized using the particular metal oxides. So here we're not going to use their bases, we're going to use their metal oxides. Understand? So when you're going to learn one method, you need to compare this with the other. So you should easily differentiate between all the different types of methods. Okay, in somewhere you have the same you can say that reactant, but there is a little bit change in them. So you need to know about the change. Now, the method is generally the same as that of the metal carbonates and an acid. Through some warming, the reactants may be necessary. As you know that why you need here to give temperature, because the metals we used here, they are non-reactive. So as I explained earlier, if sometimes reaction is not going on smoothly, then you need to give specific conditions. So here we're going to increase the temperature by warming the reactants. Okay, an example of such a reaction is the neutralization of sulfuric acid by copper oxide to produce copper 2 sulfate. So here it's just simply going to show you about this one. Like here, sulfuric acid H2SO4, that is your copper oxide. Now what going on here? From here, H is dissociated from sulfate, and from here copper is separated from oxygen. So sulfur and copper combine together, and what they form? Copper sulfate. And hydrogen comes toward the oxygen, and what they form? Water molecule. Now till here, any question?
What is the one? The
Liquid,
H2O.
liquid, L. This is L, liquid. AQ aqueous, S for solid, okay? G for gas. You know, these all are the state symbols. So here, couple of further reactions are written here. So metal oxide contain the oxides like O negative. The ionic equation for this reaction is therefore. So H and O, they give you water. And same like here, copper oxide react with hydrogen, they give you copper and water molecule. So the reaction of a base with ammonium salt. Let's start this one.
Yes, sir.
Okay, sure. Now, let's see this here. After discuss a lot about this thing, now we're going to see the reaction of a base with ammonium salt. Small quantities of ammonia gas NH3, that is the chemical formula of ammonia, can be produced by heating any ammonium salt, such as ammonium chloride, this is here, NH2Cl, that is the formula of ammonium chloride, with base. So base is your calcium hydroxide, like we use sodium hydroxide. Here he used calcium hydroxide, okay? So don't worry about that. We learned the base as calcium. Now here is sodium. So this same thing, okay? They give the same types of reactions, same types of product. I don't mean to say the same thing will be there, the types, the properties, the types of the reaction will be same, okay? Such as hydroxide. This reaction can be used to make ammonium in the laboratory like this here. Calcium plus ammonium chloride, they give you calcium chloride, okay, water. And in the end, what you get? Ammonia gas here, that is. So the ammonia produced can be detected as being formed by the pungent odor. That is the objective question. Maybe in the objective, he can ask you how you can detect ammonia gas. So the option will be there due to its pungent odor, by turning damp red litmus blue. These are two identification tests of the presence of ammonia. Understand? Yes, my
Wait,
dear.
sir. Repeat.
Uh,
There's been co-
yeah, this the types when look, if somewhere something is present, okay, if somebody asks you how you can identify there is that element or that gas or that product is present. So for this, there are few identification tests, okay, that identify these things are there. To find out or to identify the presence of ammonia, its specific identification is that its pungent odor, okay, and it turns the damn red litmus into blue, okay. Now clear? Yes, please.
Yes.
Okay. Now the almost the last part of this, preparing insoluble salts. So before all, we learn about the soluble. Now the insoluble salts. The method described above can be used to make a salt that is soluble in water. If a salt that is insoluble in water need to be prepared, a different technique is needed. An insoluble salt such as barium sulfate can be made by precipitation. You know about what is precipitation? Yes, any idea about precipitation?
No.
Okay, no problem. Uh, even you can take, you can do this experiment even in your home to see about the precipitate. What does precipitate? We'll take a half cup of milk and just squeeze a half lemon in it. The milk will become convert into little bit solid part or some liquid in it. The small particles, just like you can say that it's giving you the suspension type mixture of the milk after adding the lemon in it. These are called precipitate. The precipitate basically not soluble in water. Understand? In this case, solution of the two chosen soluble salts are mixed to produce barium sulfate, barium chloride, and sodium sulfate can be used. The barium sulfate precipitate can be filtered. It means it will not dissolve. It form precipitate there. Washed with distilled water and dried, the reaction that has occurred is here. Look what happened.
So, sir, precipitation mean that it cannot be dissolved with water, yes?
Yes, it's not dissolved. Even it's present inside water, but not dissolved. Okay. They are separated. They are moving maybe up, down, or in the middle of the liquid of the solution. Okay. Not like salt, NaCl that is dissolved in water. You can easily find out. So it's not like this. The precipitate, simply you can
It's like
see it. Yeah, but the NaCl you can't find where is it because it's disappear or dissociate in the solution. Like the same in the sugar. Then you dissolve sugar in water. You didn't find. Okay. Now,
Okay, dissociate.
yeah, the barium chloride with sodium sulfate, here you get barium sulfate, and you look here, what you get, the state symbol, what it shows you here, solid, okay? But the reaction is still continue, and you get here sodium chloride that is in aqueous solution. So this S represent here, it is in the form of solid, not as solid, you can see that, but it's present in the form of precipitate. Understand? Yes, please.
Yes.
Okay. So here you can see that the reaction you can see here when a barium chloride solution is added to sodium sulfate, white precipitate of barium sulfate is formed. So look, these white colors of just looking like a fume. These are not fumes, actually these are the solid parts of barium sulfate. Okay. So this method may be summarized as follows. So you can see this one here, the method, it shows you like soluble salt, insoluble salt, and soluble salt. You can get from here. So when you use two types, you can get a third type that is insoluble in this one. It should be noted that even salt like barium sulfate dissolve to very small extent. For example, 1 decimeter cube of water will dissolve only 2.2 into 10 raised by third minus 3 grams of barium sulfate at 25 degrees Celsius. This substance and substances like it are said to be springily soluble, mean to say not totally soluble, or you can say that partially or very little soluble. Yes, my dear. Any question till here?
Can you just repeat the last part?
This one?
Yes.
Okay, here it's going to tell you the substances that like this, okay, they are very little soluble. That's a reason they are not totally soluble in the water, and their little part is soluble and remaining will be like this. That's the reason this substance and the substance like it are said to be springly soluble, okay, not totally or completely soluble, because they are little bit soluble. That's the reason they start the reaction, but at the end, they will separate out in the form of solid particles. So let's start the testing for different salt. Yes,
Yes, yes.
okay. Sometimes we want to analyze a salt and find out what is in it. For example, you see a salt, maybe NaCl, NaOH, sorry, other salts, and you want to find what thing is present in it. There are simple chemist tests which allow us to identify the anionic part of the salt. You know that there are two things. One is the positive and the second is negative. Like here Na, that is the positive part, and Cl is the negative part. So cation and anion, you need to find out which part is present in it. Testing for the sulfate, like SO4 negative 2. It's mean it contains two more electron in this form. So how we can find out this thing? By the helping of chemicals. So look here, just what we're going to do, we're simply going to react Ba, barium ion with sulfate ion. Okay, so what you get, a barium sulfate, that in the form of solid. So you can say that as a precipitate. Look, this is aqueous solution, AQ. It is also in aqueous solution, but when they both react, what they give you? They give you a solid. Understand?
Yeah.
Like
Why?
this. Yes, why? Because they form a precipitate like here that we learned in the last reaction. Okay, because they are formed insoluble. Understand?
Yes.
Okay. So the same testing of chloride, bromide, and iodide. You can see here how they react everywhere. When you're going to react a chloride ion with silver Ag, it give you AgCl in the solid form. So the left it stand as a precipitate goes gray. So if you want to know which element is present in them, like this is the anions of chloride or bromide or iodide, it depends upon their colors because some are white or some are colorless. But here, these halogens, they show specific colors. In this case, in the case of uh, chloride ion, you can get gray. Okay. In the same way, when you move next, iodide and bromide yellow, silver for iodide. So all are written here. You need to learn about their colors. Okay, my dear. So you can see here
Then the colors
of precipitate, of the solid precipitate that form there. Like the bromide and iodide will react to produce either a clean precipitate of silver bromide or yellow precipitate of silver iodide, and like this. Okay. So these shows you different types of colors during the formation of a precipitate. So all are written here. So you can easily find out in the test tube. So it shows you AgCl, silver, chloride, a white precipitate, AgBr, a cream precipitate, and AgI, any silver iodide, is a yellow precipitate. So the alternate testing for iodide ions is the addition of lead nitrate solution to iodide, which result in the bright yellow precipitate to lead iodide. So if lead iodide, it will give you like bright yellow color. So that is all about today's lesson, inshallah. Next, we're going to discuss about the testing of carbonates.
okay.
Okay, thank you very much.
And after we finish